Sweet. So, um, yeah, so I'll go over, rehash everything that we talked about yesterday, Vitaly, and Dimitri with Jan. I don't think Jan can make it today, so it was good that we got him on the call yesterday. Well, I'll rehash it and then we can kind of pick up where we left off and first answer any questions. Shakar, I think it would be great if we can maybe look at some of the architecture stuff based on yesterday. So we'll bring you up to speed. Yeah, so I'll start from the beginning. So let me share my screen. Um, Give me 1 second.
Angelo, before you start, so that those that are listening to the recording, just start by stating the purpose of the meeting, okay? So that
Yeah.
it start by.
Yeah, so yeah, that's what I was about to do. I was about to share and start. So what are we meeting here? Hey, John. Great. So, what are we here meeting about today? So, there's going to be two topics. The first is going to be why it impacts multiple teams that are working on different features. So we'll go over that and then go over any questions, and then we'll kind of move more into some of the knowledge graph stuff if we have time. But I believe the local knowledge graph architecture plays into also the embeddings architecture, so it might be useful for the different sub teams to kind of hear the conversation. But this is mostly going to be about one problem that I hopefully aim to solve from based on what I've seen in my research throughout my time at GitLab, and that is solving a gap that I see, which is duplicative logic across many code bases, and ways that we can essentially solve that. And on top of that, actually move faster because we're now combining all of our efforts into one. So that's why I have this draft proposal up, and it's basically called one parser. And the whole premise of it is to treat the static analysis that we do throughout GitLab as a first class citizen, and have a dedicated code base for static analysis. Hey, Matt, I saw you just joined.
Hello.
So what do I mean by that? So if you I'll link the issue in the agenda doc actually. So let me link this so everybody can pull it up. Um, uh, I'll link it here. Proposal, and everybody should have that link. So essentially, we have multiple subteams. So we have the knowledge graph subteam, which is working on building a knowledge graph of repositories. We have the chat with your code base as context subteam, which is going to leverage embeddings for semantic search querying and using the abstract embeddings layer. And also on the language server side, and this is the only three topics that I can think of now, but I'm sure there's actually places throughout GitLab that can leverage this. But on the language server side, we also have a lot of tree sitter logic, which I believe can actually be solved by this same proposal here. So the problem essentially is that we are doing static analysis across many different code bases, and we don't have a unit. We're rewriting the entire, for instance, the imports. This is a simple example. We just completed DaVinci Phase 2, which is import static analysis for code suggestions on the language server. And also on the knowledge graph side, if you look at the knowledge graph POC, there we are doing the exact same import static analysis for determining import relationships in the knowledge graph. So the proposal here is saying, let's create one library in binary where we can essentially have a version library that performs the static analysis. And we treat it as essentially a contract. And any team can go in and leverage this library for extracting the information that they need. Does that make sense so far, or at a high level? Or is there any questions?
I'll just state that there's some other teams that use a lot of static analysis for years, and that's the secure team. So they've
Yes.
used static analysis for basically our SaaS
Mhm.
product primarily. And so that's another team to potentially bring in. I mean, in a brief conversation with them, some of the things I've seen, like issues with like using tree sitter for static analysis have been, our customers use like C++. Static analysis for those languages is extremely hard. And
Mhm.
so they have faced like issues with certain languages, but yeah, they essentially have the same kind of foundation already is they go through SaaS tools go through like the C++ code. Believe
Yeah.
it's written in OCaml, some of the stuff. But it does essentially the same stuff.
Yeah, yeah. So that's even a good point too. I believe most of their code bases are Go based, right?
Mhm.
Shikar.
Yeah,
Uh,
some of it is Go. I think I forget the name of the company that we acquired right now, but that one uses they use OCaml quite a lot in their code base, and so um,
Oxeye. Okay, gotcha.
Oxeye, yeah,
Side.
yeah, that's
Um, okay, great. Yeah, so that's also good to know. And like, I'm sure there's also probably a few other teams. Dimitri, I think you mentioned there's other parsers that might be able to leverage the same static analysis. Am I off?
Maybe you mean different indexers, or what do you mean by parsers?
I might have got it confused with indexers. I remember seeing a comment, but were you going to say Shakar? Sorry.
I was going to say that a good like as like before you go too deep down this path,
Hmm.
I think it's a good idea to speak to some people from Secure, like Mayor, for example. He has been working on this for like ages as well,
Yeah.
and so you could sort of talk to him about this approach. I mean, I think it is a good idea to kind of um, start working together. Uh, to figure out how to do this. And I agree. I like your approach anyway, doing it in Rust and parsing the tree.
Mhm.
Uh, but they have certainly run into pitfalls with this approach as well.
Yeah.
Uh,
Yeah, that, and I'll definitely do that. I met with Jason before from Secure about some static analysis stuff, as well as I forget his other name. He has several patents published.
mhm,
But I'll meet with them again to see any of the pitfalls. But this is also the culmination of just my research so far and comparing the different runtimes. So I was kind of hopefully wanted to go in a high level over that today, and maybe demo some things. But we can go on a different topic as well, Shakar, if you. Yeah.
mhm. No, that makes sense.
And Angelo, just to echo Shaker's point, I do like the concept of, as I can see, 4 potential projects utilizing one bit.
Mm-hmm.
Make sure that we're getting feedback from other teams like Secure,
Yep.
etc., that may have other points of view or may want to make this better, or may find some reasons why we need to think of a different approach. But I do love this concept of 4 projects utilizing one thing. But
Yep.
let you take it over.
Awesome. So the main point here is to at least get across my findings so far and maybe have a discussion. I created more of a proposal format, but basically, based on my research so far, there's at least 5 different runtimes we can use to use Tree Sitter. So at the heart of all of this has been mainly Tree Sitter. So we use Tree Sitter for a number of languages on the language server side for a bunch of different static analysis, like comment detection for code suggestion streaming, import analysis for DaVinci, intent detection, seeing how many lines or empty lines are in a file, stuff like that, in a code file, that is. And then on top of that, an AI gateway, I believe we also have some tree sitter logic as well. And then I know the embeddings team has been thinking about using chunking by class or function. I know, Shakar, you have some thoughts on like the different strategies for that. That might not be in scope for this meeting, but if you want to outline that, we can do that as well. But essentially, my findings at least were we have 5 different languages or runtimes that we could write all this logic in. Well, the first one people mainly ask is why not Python? And TLDR for Python is it's what we want to do for a library like this where static analysis and performance is mission critical. We want to avoid any type of JIT or GIL lock or anything where we are not actually compiling to bytecode. That's the first thing. And then on secondly, it comes down to interoperability and exportability. So my findings, at least for Python and JavaScript and whatnot, is JavaScript can of course be exported to WASM. But if you wanted to use JavaScript in, say, Golang, for instance, you would need to import like a WASM engine, like Wazero, and actually leverage the WASM directly via a WASM engine. So the JIT compiled languages are probably not the best option for building a library, if that makes sense. So that doesn't mean they won't be used in the various runtimes, or it can't be used in the various runtimes, but I don't think it serves as a good base for a library and the extensibility part. So then it came down to Go versus Rust, from what I found. And OCaml, I also explored OCaml, but I saw that OCaml actually moved from OCaml to Rust for the GLQL. Is that right, Dimitri?
It was from Haskell.
Haskell,
Sorry, Haskell.
Haskell.
Sorry, Haskell. I'm
Haskell
getting
to Rust.
names confused. Yeah, Haskell from to Rust to export to WASM, right? To help export to WASM. And so that in WASM, unfortunately, is if we want to use this in the way that we want to that we intend to use this, is potentially a hard requirement so that we can actually leverage it in the language server directly, because it is a Node.js runtime. And then on top of that, if we ever want to use the static analysis in the web IDE, we also need to have it be able to run in a browser engine as well. So everybody, does that make sense so far? Is that any questions?
Just so that I'm clear, just back up for a second. So background, 3 teams, knowledge graph, code base, chat, context, and GitLab language server all need a tool like this, right?
Yeah.
Okay, so that's the background, all right?
Yeah.
And it looks like there are several challenges. You listed 4. So duplicative effort, inconsistency,
Yep.
maintenance overhead, and client-side challenges. Got it. So we've got 3 teams, possibly 4, that can use one thing if it's created.
Yes.
And that will reduce duplicative effort. It'll make things consistent. It'll reduce overhead, and it will mitigate some of the client-side challenges. Am I understanding you?
That is correct.
Okay.
And
So now tell me why Rust. Talk to me a little bit about the library, why Rust, and what it brings. And I think you've got 4 things that you listed. Go through each of those with us, starting with the tree center and integration.
Yeah, so well the main heart of majority of the static analysis that I've seen is tree sitter. And like you said, Shakar, it's not tree sitter can be used really probably for everything, so it's not a one shot.
Got you.
But for the purposes of AI, at the very least, we are using tree sitter for majority of the use cases.
Gotcha.
And so it definitely will be good to talk to Secure to see if, where the pitfalls that Tree Sitter has as a static analysis engine. But for the basic purposes of AI, where we need to extract certain information, Tree Sitter has been pretty much the core of it. I think it's been proven that we're using it in production today. We're using Tree Sitter throughout the various code bases for the different libraries and gateway and language server and other places that I think we can confidently say that we're still going to at least use Tree Sitter for the interim until maybe we talk to Secure and they have we maybe even come up with a different engine.
Got
So
it.
this is assuming we're going with the Tree Sitter route. So if we're going with the tree sitter route, that's where I explored the two runtimes for tree sitter support. What best supports tree sitter? And so I'm going to skip over why Rust for now, and I'm going to go to why Golang because that's going to be the first question everybody asks. I'll probably reorder it to where this is first. And so for Golang, I spun up a Golang project. I can pull it up if you guys want to see. Um, but there are two major problems with Golang from what I've seen with Tree Sitter. The first one is the lack of interoperability. And so what I mean by that is the most used binding throughout the entire GitHub code base and GitLab code base that I found is this Smacker Go Tree Sitter bindings. And it's essentially a port of some of the code from Tree Sitter, and it creates some CGO bindings to essentially allow you to run the C dependencies, which parses the code. So it talks back and forth with the C code to run the parser and then extract the information back into something that you can interact with on the Go side. However, because it uses CGO to actually compile the C dependencies, CGO, that compiling engine, does not support WASM out of the box or natively. And I even I got into some of the LLVM discussions, and it's just not supported right now. And they don't intend on there's some discussions on being able to export CGO straight to WASM and have that entire tool chain there. But as far as the we need X products out in X time, I don't think we can necessarily wait for either the compilers to reach that support. So that means essentially TLDR for that is in order for us to export, because you can export Go to WASM. But in order to export Tree Sitter Go, we'd have to build a way for those C dependencies to also make it into the WASM, and that Go binary also interact with that WASM. So I actually found a project.
You don't need to do that with Rust, right? There's first class support for WASM with Rust, right?
Yes, yeah, I'm getting there. I'm getting there. So for Go, in order to essentially do any type of WASM, we'd have to. I found a project, which is in the details here of the Golang research. Someone actually was trying to export Go code to WASM using Tree Sitter, and they basically took the Wazero Go engine, which is compatible with WASM, and essentially built the WASM binaries for Tree Sitter, had them load and embed into the Go binary, and then they would talk with the Wazero engine so they can make calls to the different WASM binaries. So you'll find that in this project here. So if you go to this and look at it, you'll be able to look at some of the code. The downside with that is we'd have to export WASM binaries for every single tree sitter dependency, or sorry, every single tree sitter language, just like we do in the language server today. And then build bindings for every single one. So we'd be recreating the bindings from scratch, unless we use this person's library, and he did that for a few languages already. But that's a major uphill battle when it comes to even just being able to use it. And I'm not even sure if it's stable, since it's, there's like 1 star on that project, and it seemed more like a research project than anything. So from what I've seen, WASM is just not in the picture for Go. That's the first point. Any questions with that? And feel free to look at it and verify my work. I could be wrong, but I'm pretty sure based on my experience, it's not a thing, and what a lot of the threads that I researched have said. Secondly, the what I see is there's potentially a risk even with going with tree sitter in Go in the first place, and that's because the main bindings library that exists does not see much activity. So it's very similar to Apache Age and the gaps that Vitaly and Jan found with that. As far as the lack of support, there's issues on the repository that are relatively unanswered. And then on top of that, it only supports a subset of the complete tree sitter languages. So like it only supports, I think, around 10 or so languages, maybe with a few community languages. But for instance, I tried finding Zig, which is now an increasingly popular language, and it just doesn't exist for a tree sitter Go binding. So that to me is another risk when going with Golang as the runtime for it. This doesn't mean we can't use a Go binary that leverages any other binary for any type of static analysis, which is what I'll get into later. And it's actually part of Dimitri's idea. But for the actual AST logic itself, like a simple example is giving me a file, a language, I'll pass in the file and the language, and I'll get back the imports, right? That's a simple example. It doesn't seem that Golang is best suited for that. So the second runtime that I examined, or language that I examined, is Rust. And there's a few reasons why I think Rust is a really good fit. And I'd actually like to show you guys, because since we have some of the editor extensions people here, I just want to show you a project.
Before you show the project,
Mhm.
state the 4 reasons why Rust, and then show the project. So we've got the tree sitter bits, but
Yes.
talk a little bit about WASM, talk about performance and memory, and cross-language integration before you show the demo.
Yeah, so for Rust, the main point that we're again going for is tree sitter and being able to perform AST analysis on it. Tree sitter is their code base, the actual tree sitter organization that maintains tree sitter, open source organization. They have first class support for Rust. Half of their code base is in Rust. I believe they're migrating a lot of the parts of their code base to Rust. And so because they have first class support for Rust, that means every single language that you see out there usually has a crate associated with it. So Zig has a Rust crate for it. Even some of the lesser known languages have Rust crates for them. So just like in JavaScript, you can usually find somewhere a binding for a specific language, which we have. We needed to do that for the comment detection. I think we support, Lena can correct me, but I think it's like at least over 10 plus languages that we support in the language server for today with Tree Sitter. So I verified that Rust has the same number of languages that are available in JavaScript as far as the WASM bindings. So The second thing, you're gonna ask something, Maverick?
No, no.
Okay. And so the second thing is that I found a way, and it's verifiable that I found a way that we can import a tree sitter binding dependency in Rust and export that all the way to WASM, meaning that we can have 20 tree sitter dependencies that compile into one WASM binary that the language server and the web IDE can both use. And then on top of that, another binary that let's say Go wants to FFI into, or Ruby wants to FFI into, which we already FFI into several Rust binaries in the monolith today. I think we do that for one of our markdown parsers, for instance. So this means we knock out 3 birds in one stone, or 3 different runtimes in one stone with one library. The JavaScript WASM implementation, which is Node.js in the browser. So technically, I guess 4 platforms, Golang, and on top of that, Ruby, and potentially even Python. So I know, for instance, the Anthropic tokenizer, I think, leverages a Rust binary under the hood. So we can even explore seeing if Python can utilize the exact same thing. I'm pretty confident that it can call Rust via FFI. Does that make sense so far? And that was the demo that I wanted to show. But Shakar, do you have any questions or?
Yeah, so I mean, I agree with the choice of Rust for like WASM compilation. I think I think we've seen that in several projects where we've sort of analyzed, and there's valid reasons why we've sort of gone down the Go route, because we have a lot more people who know Go at GitLab, and so it's a lot easier to incorporate into the fray. But actually, we do also now have first class support for Rust in the GDK. It's been there for the last 2 years, I believe. And then also we've had, I think 2 or 3 Rust projects, like the GLQL bit is one, but we also have we use it in Ruby too for the Prometheus matrix, for the Prometheus metrics. That's something that Stan wrote a little while ago, maybe a year and a half ago or something like that. And so we're using Rust in a few places, like I think 3 or 4 places in the Rails code base. It's not like it's totally um, obscure in GitLab, but yeah, I understand those reasons. But there's a lot of difference in like the size of the WASM generated, especially for like browser. Like if you're going to do it in Web IDE and the browser has to download the WASM compiled binary, it is considerably smaller in Rust, for example. And but my question is like, why do WASM at all in the IDE? Why not use FFI and have a faster kind of interface than going over? Like, what I'm saying is that we could certainly use WASM from Ruby or use FFI from Ruby as well to kind of use this than going the WASM route, because there's nothing's faster than native. A native compile code is a lot faster than going over the WASM kind of bridge anyway. And so why not just do that instead of having to compile to WASM? I understand for the like web IDE use case we may need to compile, but depending on the use case, we can go down the more efficient route.
So that's the main one of the main points is having the WASM interoperability is big for editor extensions specifically because I can even show you upgrade tree sitter dependencies. So I handle tree sitter upgrades project upgrades in the LSP project. We had to handle this number of MRs just to be able to maintain the various different tree sitter dependencies and compile all the WASM binaries for all of these dependencies. So if we had one library that we maintain, which already has upstream dependencies from Rust, as long as we have sufficient testing and integration testing, we knock out this entire maintenance cost.
I'm still saying that. I'm still saying that we have one Rust library which does all the parsing,
Mhm.
but instead of but it exposes an FFI interface also in addition to a WASM one. So you could compile to WASM and publish that for whatever purpose.
Yeah.
But when we're including it in the IDE, we kind of talk over FFI instead of.
Yeah. Yeah, so that was actually an idea or the general thought that I had for instance, the knowledge graph. So we would, like I was saying, depending on the runtime. So for desktop, we would export a Rust binary so we can, leverage actual multi-threading and whatnot. And then we could export a WASM version for the web IDE. And you can replicate the knowledge graph in both platforms, but it would be optimized for the machine and OS that it's running in.
Yeah.
We definitely should explore that, see if it's faster, like calling FFI. Like if you're in the desktop version, call via FFI to do the parsing. We definitely can look at that for sure.
I mean, one of the main issues, like with WASM, is the fact that I don't know what the state of multi-threading in WASM is at the moment, but
Right.
the moment you want to sort of leverage multi-threading, you can't, and so that becomes an issue in WASM. It slows down. If you just run it like native code, which
Yeah.
can multi-thread versus WASM, so you could probably parse a lot faster if you parse it out of WASM. Unless you have to, like I understand the browser if you have to.
Yeah.
John, you had a point that you wanted to make before Angelo does the demo. I think you had.
Oh, I think I'm just repeating what everyone else is saying, which I think having multiple build targets makes sense. I do think that WASM to Shaker, to your point around threading, yes, that's my experience with WASM. And if you use something like Tokyo and you compile to WASM, then they just go, oh right, we're throwing down to one thread, and so yeah, I would, if possible, most things shouldn't use WASM unless necessary.
And before we start, Vitali, did you want to echo your point as well before Angelo does his demo?
Yes, I'm just everybody's comments. So definitely.
I think it's something similar. It's how I understand it is we are going to use WASM for JavaScript on editor extensions, but for backend part we don't need to use WASM. We will use, and since we cannot use Rust directly from a monolith, we wrap it into Ruby gem with FFI, and yeah, that's at least how I understand this. Maybe I'm
Yeah, that's the
That's
proposal is we'd have two build targets. So we'd have native build targets and then we'd have WASM targets. So and then consumers of the library can pick and choose whatever suits their use case. But you still have a version library that give me a file and the language ID, and you'll get back structured information. That's the whole goal of it, essentially.
Gotcha.
So and so, yeah, so I wanted to show you exactly what I mean by that. So if I go in here, I'll launch this for you guys and make it bigger. Sorry. I think I've showed already a few people, but maybe John, I don't think John has seen it. I don't think I've showed it to Shikar as well. But essentially, if I go in here, and I have this tree setter WASI web. So I found this online. Someone is basically the hack in this. If I go to the make file, is essentially we are specifying a build target, which is WASM here to the right here. And then on top of that, we are actually setting a build flag so it can actually build via the C compiler all the C dependencies as well. And so this two-line thing here is the magic sauce for actually compiling the entire thing. So I'll go ahead and just show you. So if I run npm, oh sorry, I need to go into the web. So if I run npm run build, so this is going to actually run the build here. And what it does is it generates on the left. I don't know if you guys can see it. Let me know if you can't see it well. But on the left, you can see we have one WASM binary. So rather than having 20 WASM binaries and editor extensions, we have one WASM binary. And I can even reveal in Finder to show you guys. Where is it generated? And it's roughly 20 megabytes. And this is embedding I think around 5 languages or so. So let's go into the languages. So if I go to the library here, and I go to the different methods. So let me get rid of the terminal. We have essentially all of these different parsers that we can parse the AST. And so I have Python, Ruby, Elixir, Zig, Rust, and Go all in one. And this is all using the tree sitter specific dependencies depending on the language. So you can see we have tree sitter JavaScript, we have tree sitter Python, Ruby, etc. The developer in the Rust language, all they have to think about is importing the correct tree sitter dependency and leveraging the AST, whatever logic they want to. And then if I go back here and I go to npm run start, what this is going to do is just create a little website for us to look at. And on the right here, I didn't wire up the UI for all the various languages. But if anyone gives me any one of those languages for the specific language, you'll be able to see that we can get the actual structured information for each one of the languages. So in this case, this is JavaScript. So on the right here, let me make this bigger so you guys can see. So on the right here, we have all the different languages. So if let's do like Python as an example. I think it's like I can do like some function like that and do return 1. I don't think there's a colon at the end. But you can see other languages have an error, of course, because it's not the specified language of choice. But Python actually returns a valid AST. And so this works for large code bases, large code files that I've tested with, and it works across the various languages. So that's just one demo as like a proof of concept to show you that we can export it to WASM as a build target. And then of course this also will work for FFI as well. So for a native binding. So yeah, that's the demo and kind of the overall TLDR. And then of course the challenges like Shikar mentioned earlier is the upskilling, the resource maintenance costs, and potentially development pace, and assessing whether it be a backtrack. 2 things of note. Dimitri gave some very good points that since we have some existing Rust projects already, we can follow what they have already established for crate publishing. So setting up the actual project, I don't think should be relatively, there shouldn't be many blockers, so long as we can follow their expertise. And we also have the new GLQL project, which is exporting to WASM, so we can also follow a lot of the standards that or best practices that they found there. So that was just one note on that, but we definitely can continue having the conversation on upskilling and resourcing. So yeah, that's basically it as far as this specific topic. Yeah, any questions, thoughts, concerns? Yes, no, maybe so. Shikar, you have anything?
That sounds like the right approach, according to me, like building a single parser, which you can use across 3 or 4 different sort of use cases that we have across, and I think that's makes a lot of sense to me. Yeah, I don't see like any objections here in terms of could this be a problem, could this not, like a few things like WASM and FFI. Like we used Wasm from JavaScript quite a lot, which is fine, like for the browser kind of use case. I would say we should explore like FFI first for like the use cases within IDE or the use cases directly from Ruby.
Yeah.
But again, we did explore like FFI has some oddities as well. When we encountered some bugs in like the Ruby implementation of FFI, when we were trying to well, actually, with the Go implementation of FFI with Ruby, like the interconnect, because we were trying to we've done this a few times, by the way, this whole FFI boundary thing. We were using, we compiled this dev file gem, sorry, we were compiling the dev file Go library down to FFI to use within Ruby. And we had some issues with that just because of the interconnectivity between like Go, the way Go was assuming the FFI boundary should be, and the way Ruby was assuming it should be. And so we had some issues there, but I suspect those issues would probably be lesser with Rust, especially since there's so many projects within the Ruby community which actually use FFI with Rust. And so I suspect that'll be a lot lesser thing. I think just in terms of just the maturity of both FFI with Ruby and Wasm.
Yeah.
Rust is wins on both counts just because of the maturity of the community and the
Yeah.
issues fixed already. Yeah,
That's
that's
good. Can
my
you add the links to that potentially to the proposal? Like anything that you can find?
yeah. I have this. I linked in the chat to a video we did 2 years ago. For we were doing a
I put that
different.
at the top of the references. It's in the
This
reference
is
section.
Okay.
Analysis of Go versus Rust.
Added to the agenda. Okay.
Yeah, we did an analysis for replacing our highlighting library with because the highlighting for large MRs is quite slow, and so we did an analysis of whether we could use Rust to Go for doing the highlighting. We analyzed both for Wasm.
Yeah.
We didn't choose either because still native JavaScript was the fastest, but it was something we did before, and then I'll try to find the def file thing that I just spoke about that we did a few years ago. I don't like there must be issues, but I don't remember. Again, that was around 2 years, 2.5 years ago, or something like that. When we did that analysis.
All right. So what are next steps?
So the next steps is see, I guess I don't know if how much more discussion we have on it, but the next step, like let's say we go with it, is to create a project. I don't know where that project would live since so many teams would use it. I was assuming maybe under the code creation group.
You think?
But
Yeah.
Well, let's keep it there for now, and then we can always move it after. We can put it under AI framework or code creation, wherever you choose. And then we can move it to a different group. I would suggest you do connect with the secure group with Mayor specifically
yes.
around this. I was speaking to Michael Mao a few weeks ago around the same issue. They are also kind of trying to figure out how they can build like a graph and a tree. They have to do that for their static analysis tools. And they've heard lots of like customer complaints on the sort of supported languages and the limitations that they have today. And I think they're trying to rethink this as well. And so it may be a good sort of point to connect with them. And see. Yeah. So Michael's he leads growth and secure, and so but you could speak to Mayor, who is sort of leading this effort on the SaaS side, as far as I understand.
Okay. Yeah, if you can link the contacts, that'd be great. Definitely reach out and get to them. But yeah, the part of this is we wanted to get this settled quicker than or sooner than later, I guess, because we have the chat with the code base.
Let's go ahead with it. Like I don't see any blockers here, right? Like what's the blocker here? Let's go ahead with it.
Okay.
I don't see any issues with like moving forward, but keeping people informed is important because like you may hear like 3 months later, hey, this is duplicative of effort because we've already done this sort of thing, and I don't want that to happen. So let's just
Yes.
make sure we keep people informed that we're working on this thing. I don't see any issue with like just moving ahead. The only one con that I see is like developer experience. Like if we separate out the parsing into like a separate project with versus the actual kind of processing. If they're in two
Yes.
different projects, people need to like work off two different projects. So one thing to keep in mind is developer experience. So we must just make sure it's easy for people to like bring down both projects and compile it if needed. Make it a part of GDK if you can. Like super easy to make it a part of GDK that people can just download, compile, etc., and work with it.
That's a good point. And maybe we can have different fronts for that as well. Like some people from code creation who are doing the embeddings work, like as part of the embeddings work, can work on the integrating it into the monolith. And then on the JavaScript side, some of the editor extensions people can make sure the developer experience is good there. It's a good thing that Rust automatically generates TypeScript bindings. So that's like, to me, huge. I don't know if one or Anna feel differently, or Lena, but um, yeah, it should be good. And then I think the overall design, I have a few thoughts for design. So maybe we would create like, I'm assuming an epic to get it started or something. Because there's some design considerations as well. So like, are we gonna have a schema associated with the library? Like, is there gonna be what's the expected output and input, right? I don't know if we would create auto-generate bindings. I don't know if Dimitri, Vitaly, you guys have any thoughts on that for Go or Ruby, but like the Shakar said, we need to think about input output. What is the you pass in the language ID and the string, you get back the structured information, but how do you iterate over that structured information? Is it going to be like a JSON schema that we can iterate over, or is it like a direct binding? That's sort of a question as well.
Yeah, I mean, if you could save the like a JSON parse kind of thing, like a JSON parse is slow. So
Yes,
you you so you output instead of like you just output a native object, like arrays are natively supported, so you could just output an array of things, or some sort of object of things. So you could do that too. Like, oh, here are your classes, here are your methods, here are your functions, and whatever globals or whatever else you have. So you could just output like 4 or 5 arrays out of it, like lists.
okay, yeah, that would be good. Like, I guess for Ruby, you would have some type of binding where you get back.
Yeah,
Uh,
yeah.
okay.
There's a nice little Ruby gem, I forget what it's called, which allows you to do that more easily versus like just doing the native kind of binding. I'm forgetting the name of it right now, but there are a few out there which make it easier.
Okay, yeah, we definitely should get that because that probably will help embeddings team for sure. So, um,
Maybe
All right,
one
looks
quick.
like next steps, just so that we're clear. So first thing is moving forward with this is an architectural first step. So that's first steps. Loop in the secure team. Shaker and Angelo, who were the individuals? You said Michael and what were the names?
Mayor.
Mayor?
Yeah,
Yeah.
yeah. Let me try to find his last name. He's based in Israel.
Oh, I've talked to Mayor before. I talked
Yeah.
to him when I first made DaVinci, actually.
What's his, I'll let you insert the name here. And create an epic to support this, and that can be written iteratively, Angelo, and obviously bring in more team members to
Yeah.
support that. But it looks like these are the three immediate next steps. Have we missed anything?
No, I think Dimitri, you had a comment, right?
Yeah, just want to quickly mention that we might want to minimize the number of FFI calls. I think these are relatively expensive. For example, instead of calling each file separately, we might want to batch the
Yeah.
call and send all the files, or I don't know, a large enough
So take an
batch.
array of files or something, right? Okay. That's good to know.
Awesome job, Angelo.
No problem. Well, I'm hoping like this can make people's lives easier than harder. So, and I think we'll be able to hopefully move a little bit quicker too. as embeddings team needs stuff, they add stuff to the library, which benefits knowledge graph because then we don't have to do the same work, right? Or vice versa. And then language server side, I would argue that we can eventually just deprecate all the existing AST logic that's in JavaScript that we can and replace it with this library. It'll reduce the maintenance cost probably tenfold, in my opinion.
Lena, what do you think about that? What are your thoughts?
Well, I'm supportive of this. Like, I do not know like enough details to say whether it's good or bad, but I trust Angela done a good investigation.
Got it.
Cool. Do we have these names written down before we go?
Yep, it's at the bottom of the section as next steps, okay?
Cool. Sweet. Well, thanks everybody.
Thank you.
Have a
Thank
good Friday.
Thank you, Angelo. Bye-bye. Thanks, everyone.